27A, number 1. 200 draws are made at random with replacement from the box in example 2, which is the box 1, 2, 3, 4. Someone is thinking about the difference. So the number of ones in draws 1 through 100 minus the number of fives in draws 101 through 200. True or false? The SE for the difference is the square root of 4 squared plus 4 squared. So we have the box 1, 2, 3, 4. And I do the first 100 draws. So my D equals 100. And I am counting ones. Okay? If I'm counting ones, then what is my SE going to be? Well, really, I'm drawing from this box. Does everybody get that? So my SD is going to be the square root of 0.25 times 0.75. So the square root of 0.25 times 0.75 gives me 0.433. What is my SE going to be? Well, which SE do I compute? SEP, because I'm dealing with percentages. So I divide this by the square root of 100, which is 10, and I get 4. They rounded it to 4%. Okay? Which means when I do these draws, I'm expected to get 25% ones, give or take 4%. Okay? Oh, they're... I guess it's 25 plus or minus 4. So well, they didn't do percentage. So there are two ways to look at this. Either 25 ones plus or minus 4 ones, or 25% plus or minus 4%. And because we did 100 draws, those numbers are the same. Okay? All right? You do the second draws, the second 100. So I did 1 through 99, or sorry, 1 through 100. And you're going to do draws 101 to 200. Okay? Well, you are counting the number of fives. Is it really that? Are they? What's the chance of getting a 5? 0. So your draws are still 100, and you're drawing from the box 1, 2, 3, 4, and so your box is 0.0 to 1, and your SD is going to be, well, anyway, did they do that on purpose? What does the back say? It says it's true. Did we find a typo? From the box in example 2. There are no 5s. Huh. We just found a mistake. So the answer should be false because... Oh, wait a minute. Well, no, that's definitely wrong. I think what they meant was the number of 4s. So if I'm counting 4s, then I'm essentially reusing this box, because counting 1s is no different than counting 4s. So we end up with 25 plus or minus 4 again. So what's the difference? So what we're going to do is take the number of 1s that I get. I'm expected to get 25 1s. And if you are counting 4s, you expect to get 25 4s. So what is the difference between my 1s and your 4s? Well, it would be 25 minus 25, which is 0. So I am estimating 25 plus or minus 4. You are estimating 25 plus or minus 4. The difference is 0 plus or minus what? Well, one thought is we add my SE to your SE. But that will make a number that's too big. Another thought is to average my SE and your SE. But that will make a number that's too small. So what do we do to calculate the SE of a difference? We do that Pythagorean theorem. The square root of my SE squared plus your SE squared. So we do the square root of 4 squared plus 4 squared, which is the square root of 32, which is somewhere between the average of 4 and the sum of 8. Okay, can everybody remember that? So when you're calculating difference, we do my score minus your score. And in this case, since my score and your score are the same, we end up with 0, plus or minus the square root of both of the sum of the squares of both SEs. Okay, so my score is expected to be there. Your score is expected to be there. The difference is expected to be 0 plus or minus 5.65. Okay, well, 0 doesn't make a whole lot of sense all the time, so let's make up another example. Let's say that I am counting some number and I'm expected to get 16 plus or minus 3. And you're counting something and you're expected to get 13 plus or minus 5. If we take my score minus your score, what do we expect? We expect 3 plus or minus. So one thought is to add these together, but that will always be too big. So 8 is going to be too big. The other thought is to average them. 3 plus 5 is 8 divided by 2 is 4, and it turns out that 4 is too small. So we're going to do the square root of 3 squared plus 5 squared, which is 9 plus 25 is 34. The square root of 34 is 5.83. Now, why would we want to do this? Well, this is really how a lot of statistics are calculated. So if we went back to the pain example that we've been using a lot, we're trying to decide, does this new painkiller help more than a placebo? So people are rating their pain on a scale of 1 to 20. The people who don't take the new pill get 16 plus or minus 3. And the people who do take the new pill report 13 plus or minus 5. So the difference is 3 plus or minus 5.83, and we can use that number to figure out, did it really help or not? Okay, that's what 27 allows us to do, is to take two different samples and compare them to each other. which makes a lot more sense than 26. In chapter 26, we took a sample and we compared it to the real value. Well, you never know the real value. You can estimate it from a sample, but it makes more sense to compare two samples instead of the sample and then an assumed value. All right, number 2. Box A has an average of 100 and an SD of 10. Box B has an average of 50 and an SD of 18. 25 draws are made at random with replacement from box A, and independently 36 draws are made at random with replacement from box B. Find the expected value and standard error for the difference between the averages of the draws from box A and the averages of the draws from box B. Okay. So box A has an average of 100 and an SD of 10. And box B has an average of 50 and an SD of 18. So we're going to draw 25 times from this, and we're going to draw 36 times, from this box. Find the expected value and standard error for the difference between the averages of box A and box B. What is my expected value when I draw from box A? If I take the average. So this is going back 5 chapters or so. I don't know what's in the box, but I do know the average of the box. So the average of the box is 100. So when I make draws, what is my expected average? 100, right? If the average of the box is 100 and I do a bunch of draws and I take the average, I expect my expected value is 100 plus or minus the SE for average. So the SD is 10. I'm going to divide that by the square root of my draws, and I get 2. So when I make 25 draws, my average is expected to be 100 points plus or minus 2. If I make more draws, does my average change? No. Does my SE change? Yes. If I make more draws, what's going to happen to my SE? It's going to get smaller. Right. The more draws you make, the smaller your expected error. Okay. Now, over in box B, I draw 36 times. So the expected value is 50 plus or minus what? It's 18 divided by the square root of 36, which is 6. And 18 divided by 6 is 3. Now, what if I make more draws? What happens to my SE? So the more draws I make, my standard error gets smaller. Okay. All right. Now, if this is me and this is you, how far apart are we supposed to be? So 100 minus 50 is 50 plus or minus the square root of the sum of the squares. So I'm going to do the square root of 2 squared plus 3 squared, and I get 3.6. Now what does this mean? Well, I'm expected to get 100 points plus or minus 2. You are expected to get 50 points plus or minus 3. Okay? But how far apart will my score be from your score? Our scores will differ by 50 plus or minus 3.6. Okay? And that is set A.